Here we look at indeterminate forms of type 0 times infinity. And here we have the same tug of war going on. We have a limit of f of x times g of x, and the limit as x approaches whatever of f of x is 0, and the limit of g of x is either plus or minus infinity. And the f of x is pulling the product towards 0, and the g of x is pulling it away from 0. So we have this tug of war, and we're not so sure which of the functions is going to win, or whether it's going to settle into a state of equilibrium. Here's an example. The limit as x goes to infinity of x times tangent 1 over x. As x approaches infinity, the x factor goes to infinity, and the tangent of 1 over x approaches tangent of 0, which is 0. So the tangent factor is getting smaller, and the x factor is getting larger, and we're not exactly sure which one will win the race, or if one will win the race. So one thing we can do immediately is convert this type of indeterminate form to an indeterminate form of the previous type, either 0 over 0 or infinity over infinity, by rewriting this product. So we have f of x times g of x is f of x divided by 1 over g of x, and also it's equal to g of x divided by 1 over f of x. And one of these forms is an indeterminate form of type 0 over 0, and the other one, when we take the limit, is an indeterminate form of type infinity over infinity. So we can apply L'Hopital's rule, if it's appropriate, to this rearrangement of the product. Let's look at our example. The limit as x goes to 0 of x times tangent 1 over x. Well, let's rewrite this into an indeterminate form of type g of x over 1 over f of x. I prefer to invert the x here because I'd rather deal with 1 over x than 1 over tangent of 1 over x. So let's rearrange our limit to the limit as x goes to infinity of tangent 1 over x over 1 over x. Now we can legitimately apply L'Hopital's rule to this limit. It's an indeterminate form of type 0 over 0. And taking the derivative of numerator and denominator, we get that our limit is equal to the limit as x goes to infinity of minus 1 over x squared times secant squared 1 over x over minus 1 over x squared. And that's using the chain rule to find the derivative of tangent of 1 over x. Of course, the minus 1 over x squares will cancel, and I'm left with the limit as x goes to infinity of secant squared of 1 over x. And this, of course, is equal to the limit as x goes to infinity of 1 over cosine squared of 1 over x. Here 1 over x is approaching 0 as x approaches infinity, so cosine squared 1 over x is approaching cosine squared of 0, which is equal to 1. So my limit is 1 over 1, which equals 1.